Good morning, friends. Welcome back to the class. In this session, we are going to understand few techniques to solve integrals. So, why the techniques are required? The first question coming in our mind, right? So, every time the given function is not in the standard form, to apply the formula to get the answer. Like, if you are having any standard form like this, then you can directly write the answer with the help of formula. But if the given function, given integral, not in the standard form, we need to reduce them into standard form. To reduce them into standard form, we require few techniques, right? Among that, the substitution technique is very famous in the integral calculus. So, as a beginner, first we'll try to understand how and when and where this substitution technique will work. So, first of all, the question purpose is clear कि why we are using these methods and techniques is just to reduce the given integrals into standard form. The purpose is clear. And the next question coming in your mind, where to apply this substitution technique. So, first, the substitution technique will work where the function is in the form of composite. If the integral is in the form of composite function, right? Function of function. Second case, apart from that, if the derivative of the function is available in the function itself, right? By assuming some quantity as another variable, if you found the derivative is available, then you can use this substitution technique, right, without any hesitation to reduce the function into standard form so that you can apply these formulas to get into the answers, right? So now let's experience that one with the help of substitution technique. I am taking few sums which is from NCERT textbook, again the first exercise, and then also I will take the second exercise in this session, and we will cover maximum 10 to 15 sums, and because they are very small to solve, right, we can take this in a one session. Apart from the problems and all, we are going to derive the four formulas of tan x, sec x, cosec x and cot x with the help of substitution method only. You can see the list of fundamental formulas. We were having the starting formula of sin x and cos x directly, but we don't have the formulas here. Integral of tan x, integral of cot x, integral of cosec x, integral of sec x. And these four formulas can be derivable with the help of substitution technique. That also we will cover in this session. So let's take the question from exercise 7.1. So I am taking the questions from first 7.1, and also we will take the question from 7.2. Both exercise will take together, right, which will serve better for substitution method. Right. So purposely I am taking the question from the textbook which will help you to complete the work. Yes. So always we'll start with I is equal to question. Question is sine of 2x and dx. You can see here the given function f of x is basically a composite function. See, here 2x is a polynomial function or linear function. In place of theta, the algebra is coming. So it's called function of function. Hence, in this case, you can use the substitution technique. And if we observe the derivative of 2x, the second thing is derivative must be exist. Then only we can use substitution technique. Otherwise, it's not possible. So 2x derivative is 2. Hence then that 2 can be taken as a constant which is outside the integral, and ultimately this function is reduced to a standard form. Let's see how the substitution technique will work. So what I am taking here, first of all, this 2x, right? Let the 2x is equal to, it may be t, it may be y, whatever you want, right? Basically, we assumed it as t. T is a variable again. So when you are assuming any function as t, then you need to do the derivative, right? To change the dx also, because अगर आप इंटीग्रल में किसी भी वेरिएबल को दूसरा वेरिएबल से रिप्लेस करते हो, राइट, सो dx भी चेंज होगा, राइट। तो इसीलिए हम जिसको भी हम t एज्यूम करते हैं या y एज्यूम करते हैं, आपको डेरिवेटिव कर कर उसमें से dx की वैल्यू भी आपको निकालना होगा। इसके लिए हम लोग विद रिस्पेक्ट टू t यहां से हम लोग डिफरेंशिएट करेंगे। सो विद रिस्पेक्ट टू x, सो अल्टीमेटली यहां क्या होगा, 2x का डेरिवेटिव 2 और t का डेरिवेटिव हो गया dt बाई dx। सो अल्टीमेटली क्या हुआ, dx की वैल्यू की बात करूं यहां से 2 इंटू डी एक्स इज इक्वल टू डी टी, या मैं कहूं dx is equal to dt by 2. So when you are assuming some function as t or y, so you have to do the derivative of that function in general way, and we'll find the value of dx in that, and we'll change dx as well. So two things are simultaneously changing. Now see. So I is equal to, now what the function becomes, sine t into, in place of dx what I have to write, dt by 2, right? So this is what the function now becomes, sine t into dt by 2. So since 1 by 2 is a constant, we can keep this outside. Always keep the constant outside the integral so that you can get a proper idea. So I is equal to 1 by 2 is outside. So what left here? Sine t into dt. Now you can see if the function becomes a standard form. Sin x integral is minus cos x. Hence, I is equal to 1 by 2 into its integral value is minus cos t plus c. That's it. Again, don't remember to replace the with the original variable. अगर x में फंक्शन है तो आंसर n में फंक्शन x में ही होना चाहिए। तो यहां से t की वैल्यू दोबारा चेंज कर देते हैं। सो यहां आपने एज्यूम किया था 2x is equal to t, और t की वैल्यू वापस 2x से रिप्लेस करें। सो माइनस 1 by 2 cos 2x plus c. So this is your final answer. So if you understood the process of substitution technique, what generally we do first we observe it's a composite function. Second is its derivative is also available because 2x का derivative होगा 2, and 2 को हम इंटीग्रल का कांस्टेंट समझ कर, कांस्टेंट ऑफ द फंक्शन समझकर उसको हम बाहर रख सकते हैं। इससे उस फंक्शन के ऊपर कोई इफेक्ट नहीं है। सो इसलिए हम लोग क्या कर सकते हैं, उसको t एज्यूम किया, पर t एज्यूम करना इसका मतलब है कि उसको डेरिवेटिव करके विद रिस्पेक्ट टू x dx की वैल्यू फाइंड आउट करेंगे और dx को भी चेंज करेंगे। तो दो चीजें एक साथ चेंज होंगी। टू थिंग्स विल change simultaneously. One is the variable, that is whatever you are assuming, along with that dx will also change. So dx की वैल्यू पुट करेंगे और सिंप्लीफाई करके कांस्टेंट्स को बाहर रखेंगे। Ultimately the function become a standard form, and with the help of the standard formula you will be able to get the answer, but at the end again replace the t with the original variable. So this is a process. Now with the help of this process, now you will be able to solve the next question. If the question is given, e power 2x. I am solving the next question, question number 3. Question is given like e power 3x dx, right? So now just see, we are having the formula of e power x dx. Integral is e power x only. So, but we are having 3x in place of x, which we called as function of function. And the derivative of 3x is a constant. So, hence we can assume 3x is equal to t. If the derivative of any function is a constant, you can simply assume it as t. It also serves better. So let first of all the question I is equal to e to the power of 3x dx, and then take let 3x is equal to t, then derivative of 3x is 3, derivative of t is dt by dx, hence dx is equal to dt upon 3, and then change 3x as well as dx in the question. Therefore, the question is modified like e to the power of t into dt upon 3, and 1 by 3 as a constant you can keep outside. We are left with e power t into dt. So now 1 by 3 into e power t dt, the answer is e power t only plus c. Don't forget to write plus c. And at the end, again change the t with the original variable. T will be what? X plus c. So this is your answer. I hope you have understood the method of applying substitution technique, where the by assuming the function, particular function as t, if we are getting a constant, it will also work. Second, I am going to take few questions where the function differentiation must be available. Yeah. Now, if your 7.1 is over, we'll take 7.2. Now, before we start the 7.2, yeah, let us take, no problem at all, whether you are taking the sums first and then go for the formulas. Yeah, it doesn't matter. Yeah, I'm taking the question now, right? Like I is equal to 2x into sine of 2x plus 1, sine of x square plus 1 dx. Now you can see again it's a function of function as well. If you observe the x square plus 1 function, its derivative, right? X square plus 1 derivative is 2x, and the 2x is available in the function itself. So hence here the substitution technique will work. So friends, remember, when you are taking it as t, either the function derivative must be converted into a pure constant, or its derivative must exist in the question itself. There are two purposes. Again, I am speaking in another way. जब आप कोई भी फंक्शन को डिलेट करते हो, यहाँ दो पर्पस होनी चाहिए. या तो उस फंक्शन का डेरिवेटिव कांस्टेंट में कन्वर्ट हो जाए, या उस फंक्शन का डेरिवेटिव उसी फंक्शन के अंदर अवेलेबल हो. तो एक्स स्क्वायर प्लस 1 का डेरिवेटिव 2x है, और वो 2x यहाँ अवेलेबल है. इसलिए यहाँ सब्स्टिट्यूशन टेक्निक वर्कआउट होता है. तो दिस इज व्हाट, before you apply substitution technique, you have to observe the question carefully by inspection and then go for the substitution technique. Fine. So first what we are taking here, let x square plus 1 is equal to t, and do the derivative with respect to x. So ultimately it become 2x, constant derivative is 0, is equal to dt by dx. So ultimately dx is equal to dt by 2x. Now change dx and this both the variables together. So I is equal to 2x into sine t into what will happen? Dt by 2x, and this 2x get cancelled. I think now you have observed why we are taking this way, because when you are taking the function as t, derivative will get cancelled. So finally we'll always left with a standard format, a standard function sin t. So sin t integration is minus cos t plus c. So ultimately again you need to change the value of t with the original function, that is x square plus c in your final answer. It's so simple and beautifully you can apply and you can enjoy the sums, right? So let's take the another question where you will see the next question I'm taking. The question is like that is integral of sine of tan inverse x upon 1 plus x square dx. So if you closely observe this function, you will find the tan inverse x derivative is 1 upon 1 plus x square, right? So here by assuming tan inverse x is equal to t, the 1 by 1 plus x square derivative is available, hence you can go for substitution technique just by taking tan inverse x as t, hence ultimately dx will also change two things at a time. Okay, so first let's take tan inverse x is equal to t and do the derivative with respect to x. x के respective में ही differentiate करिए. तो tan inverse x derivative is 1 by 1 plus x square is equal to dt by dx. Hence we are looking for dx, do the cross multiplication. dx will be dt into 1 plus x square. Hence now dx also we got. So now just replace these two things in the question. So sine it becomes t upon 1 plus x square into, in place of dx you can write dt into 1 plus x square, and this will be get cancelled. So I is equal to what you will get, sine t into dt, and the derivative integral of sine t is minus cos t plus c, and replace the t with the original function, that is from here in the beginning. T will be written as tan inverse x plus c over. So this is what the substitution technique. Now with the help of this technique, we are going to derive the four important formulas of integration of tan x, cot x, sec x and cosec x, one after the other. Okay, so let's have a discussion on that. Four important formulas, right, with the help of substitution technique. Yeah. Now I'm taking like integration of tan x dx. We are going to derive this formula as well. We are going to derive the formula of integration of cot x dx both, right? We don't have a formula of integration of tan x directly, right? But if you convert into sine and cos language, you will get an idea how to get the formula. Tan x can written as sin x upon cos x, and dx, right? So simple. Here the sin x derivative is available as cos x. Yeah, cos x differentiation is available, what we called as minus sin x, right? So both the way you can speak, but again the question is better to take cos x as equal to t, right? Automatically converted into standard form. What is our purpose again? To apply any method to solve an integration is to what? Convert them into standard format. This you have to keep in your mind. Here we have a two options again, right? अब sin x का derivative देखे तो cos x है, cos x का derivative minus sin x, both are possible. मैंने दोनों आपको दिख रहे हैं, but only one substitution will work perfectly. So here I am taking cos x as t. So if you take cos x as t, so what will happen here? Let's say let cos x is equal to t. So ultimately what happened? Minus sin cos x का derivative minus sin x, t का derivative हो गया dt by dx. So ultimately dx will serve as dt minus dt upon sin x or dt upon minus sin x, and then change dx as well in the question. I is equal to integral of, now we have sin x upon t into dt upon minus sin x. So sin x will get cancelled. So I is equal to minus can be taken outside so that we can have a perfect formula. 1 by t dt is log t. So I is equal to minus of log of, when you are taking the log formulas, always keep a modulus symbol here. Log t, right? Log t plus c. Yeah, I is equal to minus log of, what was t? Cos x. So cos x plus c. So this is a formula. But for sake of convenience, what we will do, we'll modify this formula somehow to avoid this minus sign. Because हमें minus sign याद रहता है, कभी याद भी नहीं रहता है. तो इसलिए माइनस साइन को एडजस्ट करने का तरीका क्या है? इस माइनस वन को पावर में लेके जाएंगे तो इट बिकम्स cos x होल पावर माइनस वन. Cos x whole power minus 1 means 1 by cos x, and 1 by cos x is what? Sec x. So this is also written as log of modulus sec x plus c. या तो आप माइनस के साथ बोलना चाहोगे तो माइनस लॉग cos x होगा, माइनस एडजस्ट होगा तो कैसे होगा? माइनस वन पावर में जाएगा लॉग की फॉर्मूला से. Cos x power minus 1 means 1 by cos x. 1 by cos x means sec x. So log sec x plus c is a formula of integral of tan x. So now the purpose is solved. In a similar manner, you can go with this. Cot x can be written as cos x by sin x. Now by assuming this sin x is equal to t, so what you will get? Its derivative is available again. So let sin x is equal to t. Its derivative is cos x, and which is equal dt by dx. So dx will be dt by cos x. Now therefore I is equal to, you need to change dx as well. So cos x upon t into dt by cos x, it cancel out. So we are left with 1 by t into dt, and 1 by t integration is log of modulus t plus c. I is equal to log of modulus t has to be replaced with sin x. So modulus of sin x plus c. So you got a formula. Integral of cot x is log sin x and tan x integration is log of sec x. Right? So these are the two important formulas. Again we are going to derive log integration of cosec x and integration of sec x also. Right? By using the same technique, that is the substitution technique. Now next take the question that I is equal to integration of sec x dx. Right? Now if you convert them into sine cos, you are going to get 1 by cos, but it has no use at all. Right? So in this we need to think rationally. Right? So ये जो thought process है, by practice only you will get. Right? So what I am doing here to get into a substitution technique, I am multiplying, dividing this quantity with a specific quantity sec x plus tan x by sec x plus tan x. I am multiplying, I am dividing with this quantity purposely so that I can get something which is required. See. So when you multiply the factor into that one sec square x, it becomes, and it becomes sec x into tan x upon the same factor sec x plus tan x and dx. Now by doing this modification, what is the benefit I am going to get? So if you take this function entire denominator as t, so the sec x derivative is sec x plus tan x derivative is sec square x. The entire derivative is available in the numerator. So this is a purpose to modify the question like this. Sometimes you need this type of techniques in some questions, right? So ultimately now what I'm going to take, let sec x plus tan x, the entire function, entire denominator as t. So ultimately its derivative is what? Sec x tan x into tan x derivative is what? Sec square x, right? Is equal to what? Dt upon dx. So dx will be what? By doing cross multiplication, dx will be what? Dt upon the sec x tan x plus sec square x. So ultimately this is going to be get cancelled with the denominator. Now change this as with the t and dx. Both the substitution will be done in the function. It becomes what? C. Sec square x plus sec x into tan x upon t into dx will going to change with this one. dx की value change हो रहा है. dt upon sec x into tan x plus sec square x. These two will be completely get cancelled. We are left with 1 by t into dt, that is log t, that is log of modulus t, which is equal to log of modulus t, means the function which we have assumed here. It becomes what? Sec x plus tan x plus c. So this becomes the formula of integral of sec x is log of sec x plus tan x plus c. Right? So in a similar manner, I'm giving you a homework here. You can also find the integral of cosec x dx. Here I'm just giving a hint to start with, right? And you can go with the same manner to get the formula of integral of cosec x. Just you need to do some modification in the question, like cosec x is multiplied by cosec x minus cot x upon cosec x minus cot x. Multiply, divide with this quantity, and again the same way, multiply inside. By assuming denominator as t, the entire numerator will be the derivative of this function. Its derivative is available, hence take this entire denominator as t as we did in this format. That's it. You are going to get the formula as log of cosec x minus cot x as an end answer. So I am leaving this solution for your on you as a homework. Fine. So with the help of these four formulas, you can perfectly solve 7.2 exercise. Still, I am taking few more questions where we can see the substitution technique. So the four formulas which we have derived today, I'm just listing that formulas which we have derived. Integration of tan x is log of sec x plus c. Integration of cot x dx is equal to log of sin x plus c. Integration of sec x dx will be log of sec x plus tan x. Integration of cosec x is equal to log of cosec x minus cot x. So these four formulas, now you have to remember to apply this in various questions. Okay. So now I am taking few sums from the exercise itself. Let's see. The famous question, many a time this question is asked in boards. I is equal to 1 upon x plus x log x plus x log x and dx. Nothing is there. You need to take dx. Fine. So if you directly observe, nothing, you are going to get an idea. But if you take x as a common factor from denominator, you will definitely get an idea about this question, right? So if you take x as a common factor, you will get like 1 plus log x dx. Now, if you observe, right, 1 plus log x, if I assume 1 plus log x as t, so derivative of 1 is going to be 0 and log x derivative is 1 by x and that is available. Hence, by assuming 1 plus log x as t, I am going to get the derivative 1 by x that is also available in the question itself. Then substitution technique will work. Let's take this then. So let 1 plus log x is equal to t. So ultimately the derivative is 1 by x is equal to dt by dx. By doing cross multiplication, dx will be dt into x. And then replace this dx. I is equal to 1 by x into t into dt into x. X get cancelled. So 1 by t into dt, that is equal to log of modulus t plus c, and t has to be replaced with the original function, hence it will be like this. So this is your final answer. So friends, sometimes from the question you are not getting a proper idea, so no need to worry. Just you need to observe the question very closely. By doing some small modifications in the question, you will be able to get the idea which function derivative is available in the question. So before you start, you need to take a pause and think twice. So this is the ideology behind this. Always think twice before you start. And this is going to a very big solution to start with integrals. Fine. Now I am taking those questions where you require this type of some small tips, right? So on the same exercise, I am going to take like fine question number 10. See, it's question like x minus root x dx. So if you are observing closely, you are not able to guess which function derivative is available over here. But if you do some modification, you will definitely get an idea. Like if I am writing this x as root x the whole square, then you will be able to get some idea properly. So I can take root x as a common factor. The question becomes like root x minus 1. Now friends, you can very easily guess by assuming root x minus as a function t, its derivative is 1 by 2 root x. Root x derivative is 1 by 2 root x, minus 1 derivative is 0. So hence the entire function derivative is 1 by 2 root x. Hence 1 by root x is available. That is enough for us. So the 2 can be manageable. Okay, because it's a constant. So that is why let root x minus 1 is equal to t, and derivative is 1 by 2 root x is equal to dt upon dx. By doing cross multiplication, dx will be dt into 2 root x. And then I is equal to 1 upon root x into t into dt into 2 root x. So root x get cancelled. 2, since it's a constant, you can take it outside. We are left with 1 by t into dt, and hence the answer would be 1 by t integration is log t or log of modulus t plus c, and the t can be replaced with t को हम replace वापस original function से replace करेंगे plus c over. So here what we learned from this session is sometimes the function derivative is directly appear or visible clearly in the question, sometimes not. So where the function derivative is there but it is not visible clearly means your IQ will be tested over there. So that is what the integral purpose is. So here what I did, I have modified x as root x the whole square. Then I have take root x as a common factor. Hence then I got an idea. The function derivative root x minus 1 derivative is 1 by 2 root x is available, and then I can go for substitution technique. Fine. So in this manner, now I am taking one or two more sums and then we'll wind up this session over here. Yeah, I'm just erasing this one. Yeah, I'm taking like question number 20. I is equal to e to the power of 2x minus e to the power of minus 2x upon e to the power of 2x plus e to the power of minus 2x. Simple. It's so simple. It's look like complicated, but it's so simple if you observe closely. If you simply assume this entire function as t, you will see orally you can think e power 2x derivative is e power 2x into 2. E power minus 2x derivative is minus e power minus 2x into 2. So the 2 can be manageable as a constant, hence its derivation or its differentiation is available. It's differentiation available, hence we can go for substitution technique. So again the same way, let e power 2x plus e power minus 2x, the entire function as t, and go with the derivative. Its derivative is e power 2x into 2. and similarly e power minus 2x derivative is e power minus x into minus 2 is equal to dt by dx. So I can take 2 as a common factor. So e power 2x minus e power minus 2x is equal to dt by dx. So hence dx, by doing cross multiplication, dx will be dt upon 2 times of e power 2x minus e power minus 2x. Now change this as well as this, both the things together. So I is equal to e to the power 2x minus e power minus 2x upon this becomes t into, in place of dx we can write dt upon 2 times of e power 2x minus e power minus 2x. This will be entirely get cancelled. 1 by 2 as a constant, I can write it as outside. So 1 by t into dt, which will be served as 1 by t into log of modulus t plus c, and t has to be replaced with the original function to get the final answer. So this is what the question is. Now before wind up the class, I would like to take question number 19 too. I is equal to, in a similar manner, e power 2x minus 1 upon e power 2x plus 1. It's also a famous question again. They used to ask in boards frequently. Now see, if you are doing a small modification the question, again you are going to get an idea. I'm just giving a hint. I'm not going to solve the entire sum. If you are dividing the numerator and the denominator by e power x, अगर आप इससे divide करोगे, what you are going to get, what the function is going to modify. See, अगर मैं हर एक टर्म को e power x से divide करूंगा, इस तरीके से numerator divide हो रहा है और इसी तरीके से denominator भी divide हो रहा है. I am dividing the numerator and the denominator with e power x. So here the powers are subtracted. Here powers are subtracted. It becomes e power x, and the reciprocal of 1 by e power x written as e power minus x. Similarly, e power x plus e power minus x dx. Now these two are becomes the similar functions. The same technique you can go. If you observe denominator as the entire function as t, its derivative is available in the numerator, hence you can go with the substitution technique. So in some questions you required some small modifications to get into the substitution technique to convert them into a standard form to get the integrals. So friends, with the help of today's session, I definitely ensure you that if you go to the video lecture, you definitely get an intuition to start with the exercise, and let's experience this by solving each and every question from the NCERT, including the solved examples with the help of this video, right? So thank you all of you for watching me since so long. It's almost 40 minutes. So keep watching, keep learning and keep growing. In the second, that is the third session, the next video, we are again going to discuss few more patterns which will basically based on trigonometric functions, and we will cover maximum patterns in that, where with the help of that you can solve the 7.3 exercise, that is the NCERT based. So thank you for watching again. Thank you once again. So take care of yourself and bye bye. See you.